but I'll be on it always, always and ever.
Hi guys, welcome back to the Pink Chemist. So today we are going to do grams to gram stoichiometry. This is so exciting. I love doing gram to gram stoichiometry. So not to take too much of your time, we are going to hop right on into it. Okay, so if you haven't watched any of the previous videos, I highly suggest that you start from the mole to mole video and then guide your way to the gram to gram, which is this video. So our first step, we learned that we have to first balance the equation. If you don't know how to balance equation, I do have two types of ways that you can balance equations. So go ahead and check those videos out. But for the sake of this video, I'm going to go ahead and write the balance equation already. Okay. So we will have 3 here, 2 right here, which means this will be 3, and this will be 2. Okay? So now that we have our balance equation, that's going to be very critical to our stoichiometry for today. You need a balance equation. All right? Our next step is to list out your given and your want. Now, what I like to do is go ahead and create like a little list where I have my given and my want, okay? So as I read my equation, it says a mass of 45 grams of aluminum will react with how many grams of zinc chloride? So I see that I was given 45 grams of aluminum. And then I see that I want grams of zinc chloride. All right. So next, now that I know that I'm going for grams to grams, I am going to use a process called railroad tracks. Now, you may not use railroad tracks. All my railroad tracks are giving me an organization box for my fractions, for my numerator, my denominator, and when I multiply, okay? So if you don't like the railroad tracks, you can just go ahead and write the multiplication. So I know that when I'm going for gram to gram, I am going to have 3 railroad tracks, okay? So in the first box, I am going to start with my given. So I was given with 45 grams of AL. And then I'm going to actually go to my very last box because I was given my want. So I want grams of zinc chloride, okay? So now that I have that, I need to fill in my other 2 boxes, okay? I need to go ahead and fill that in. So I'm just going to go ahead and start. I see that I was given, my given units were grams of aluminum. So I'm going to go ahead and write grams of aluminum in this box. So diagonally, I want to have the same unit and element or compound so that I can ultimately cancel them out to only be left with the gram, not the gram, well, yes, the grams, but the units in the compound that I want. And in this case, that is grams of ZnCO2. Now, in my numerator for this box, I am going to have the mole of Al, okay? And then now that I have the mole of Al in my numerator here, in my denominator diagonally, I'm going to have the mole of Al. That way I can cancel out my units, okay? And then in my numerator, because I'm trying to get the grams of ZnCO2, I'm actually going to have the mole of ZnCO2 because this is the compound that I'm trying to get to. And if I got the mole of ZnCO2 in the numerator here, I'm going to need that in my denominator that is diagonally across. So if you notice, there is a pattern, and I like to look at things from a pattern point of view, but my elements and my units that are diagonal from each other, they are the exact same. That means that I am going to cancel out these like units to only be left with what I want. Now, my next step, I'm going to go ahead and fill in my numbers. What is it that I want? Okay. So anytime that I see that I have mole over grams, you see how you got mole over gram there? All right. you're going to always have 1 as your mole. Now, a common mistake that people like to make is they like to add the coefficient there, but that is not technically what you're going to do when you have a mole over grams. You only do that when you have a moles to mole ratio, and you'll see that when we do our next box, okay? Now, anytime that I'm going to go ahead and move to my denominator, but anytime that I have the unit grams, I know that I have to find my molar mass, okay? And I got to find my molar mass of the element or the compound that they have given me. So the molar mass in this case for Al will be 27, and I find the molar mass on my periodic table, okay? Now I'm going to go to my next box. My next box, I have mole over mole. You see how I have mole over mole? Mole in my numerator, mole in my denominator. Now this is when I use the coefficient. When I have mole in my numerator and mole in my denominator, this is how I know that I am using the coefficient. So I am going to find the coefficient of ZnCO2, which is right here, and that is 3. So my coefficient is going to be my number of moles, okay? And then for the mole of Al, my coefficient in front of Al is 2. So my number is going to be 2 here. All right. And then as we get down to our final boxes, I now have to do the same thing. I have grams again, so I have to find the molar mass of this compound. Now here, I actually have to make sure that I find the molar mass of each element. So I got Zn and I have Cl. I see that I have a subscript of 1 for Zn and a subscript of 2 for Cl. And now I'm going to multiply those numbers by, well, my subscript by the atomic mass of those elements. So zinc has an atomic mass of 65 and Cl has an atomic mass of 35. Okay. So then I'm going to multiply these numbers. So I have 65 and then, 1 second, let me do the math. So 2 times 35 is 70. Okay. Then I'm going to add those numbers up. So 70 plus 65 is going to give me 135. So I'm going to go ahead and put 135 in this box because that is my molar mass. Now, again, I have grams in my numerator and moles in my denominator. So I know that my mole is always going to be 1 here. And now I have to do the math, okay? So for some of you all, you may have, instead of doing the railroad tracks, you may have did the multiplication sign. But for those of you that did the railroad tracks, I want you to go ahead and write the multiplication signs so that you can see that you're going to multiply your numerator and get the sum, and then you're going to multiply your denominator and get the sum, and then divide those numbers. So I'm going to multiply 45 times 1 times 3 times 135, which gives me 18,225. All right. And then I'm going to multiply 27 times 2 times 1, and I get 54. Okay. Then I'm going to divide my numerator by my denominator, which gives me 337.5. Lastly, I have to get my units, okay? So I'm going to cancel out my like terms. As you can see, all of my like units, I cancel them out. And I see that in here, I'm left with grams of ZnCl2. And that is my answer. All right. Well, I hope that helps. See you in the next video.
Don't play with it, don't be dishonest. Ay, still not a